this video, we're going to talk about solving rational equations. Here is the example of a rational equation right here. The majority of this video will be spent on solving this and talking about all the ins and outs on how to solve an equation like this. Before I directly attack this, though, we need to talk about two concepts. First of all, we need to talk about finding the least common denominator between two or more rational expressions. And second, we need to talk about the excluded values of rational expressions. If you've made it this far, the expectation is that you understand how to add and subtract rational expressions. In this case right here, I have three rational expressions. If I was being asked to add or subtract, the question is, what is the least common denominator that I would use? Well, to understand this, you need to understand that the only way to build into a least common denominator is using multiplication. What I would do here first is I would factor this. This is the only of the denominators that can be factored. This will factor very usefully in this case into x minus 4 times x minus 7. Therefore, if I was going to add these together, and now I don't actually have to, I'm just being asked to identify the least common denominator. But if I was going to be adding these together, what I would do is I would multiply this expression by x minus 7 in the top and the bottom, the numerator and the denominator. This expression right here, I would multiply by x minus 4. And in doing so, what I would get is a situation where all three of these expressions here would have the same denominator of x minus 4 times x minus 7. Therefore, the least common denominator of these expressions right here is x minus 4 times x minus 7. I want to make the note that there are many different ways to find the least common denominators of rational expressions. The internet and other textbooks have lots of different methods for doing this. Me personally, I think this is the fastest, most efficient way to identify a least common denominator by asking, if I wanted to add these together, what denominator would I use? Let's now talk about excluded values. By the way, the conversation for excluded values is very similar to the conversations of the domain of rational functions. In this case right here, excluded values are the values that cannot be input for x into this equation. And again, you should be thinking, well, I should be allowed to plug in any value. Again, if you're going to check a solution to this equation, you would plug that value in for every x value in these expressions and to see if both sides of this equation agree. There are two numbers in this case that cannot be input, and those are the x values that will make denominators equal to 0 because division by 0 is not defined. I'm going to break down this conversation by the term, but the idea is collectively what values are not allowed for this equation. First and foremost, there's an excluded value for this first term. X cannot be 4. X equals 4 is an excluded value because if I plugged in a 4 in here and here, I would get 4 over 0, or 4 divided by 0, which is an undefined operation in mathematics. Similarly, in this case, for this term, the x equals 7 is an excluded value. That is the value that makes that denominator equal to 0. Finally, for the last expression over here, I would need to first factor this to identify the excluded values. And in this case, for that final term, it has two excluded values. The excluded values are 4 and 7. Those are the values that if I plug in for x will make this expression equal to 0. I'm using the zero factor property to do that. What I would then say are the values of x equals 4 and x equals 7 are excluded values. Or in other words, those are not allowed to be plugged into this equation, and therefore they cannot be solutions to this equation. Now that we've reviewed how to find the least common denominator between rational expressions and excluded values, let's tackle this problem right here. The first thing that we want to do is identify the least common denominator. In this case, it's the same example we were talking about previously. I would factor this quadratic right here. I would identify the least common denominator of these three expressions to be x minus 7 times x minus 4 because those are the only factors we see right there. So identify the LCD to be x minus 7 times x minus 4. What I'm going to do now is I'm going to multiply each of these terms by the LCD. So the second step is to multiply each term by the LCD. All right, here I've rewritten this equation. I've simply multiplied each of these terms on both sides of the equation by this least common denominator of x minus 7 times x minus 4. The goal of this is to clear the fractions, is to get rid of these denominators in each of these terms. And how this works, by the way, is I can think of this as x minus 7 or x minus 4 over 1, and think about multiplying rational expressions. When you multiply rational expressions, you cancel common factors. So in this case, I'm going to cancel these x minus 4s in this term. In this term right here, the x minus 7s cancel each other out. And on the right-hand side of this equation, both of these factors in the denominator cancel both of those. That's entirely the goal. We use the least common denominator because the least common denominator will cancel all of the factors in the denominators. What we're left with then is simply the results of the stuff in the numerator. So in this case, I have x minus 7 times x. In the second term, I have x minus 4 times 1, which doesn't really do anything, so let's write it as x minus 4. And on the right-hand side of the equation, I have negative 6x plus 12. So the move here of multiplying every term by the least common denominator cleared the denominators from my equation. Now I'm left with what will be a quadratic equation. I'm going to clean things up and focus on solving this. I need to remember, though, that I have these restricted values, or in this case, answers that cannot be true. Those would be 7 and 4 in this case, because 7 and 4 are the values that make these denominators 0. All right, now to solve this equation right here, I'm first going to distribute this x to both terms here to get x squared minus 7x. I now need to distribute this negative through both of these terms to get negative x plus 4 equals negative 6x plus 12. This is a quadratic equation because of this term right here. What I'm going to do is set one side equal to 0 and hope that I can solve by factoring, which is by far the easiest. So let's get x squared minus 8x, putting those two terms together. Now what I'm going to do is to add 6x to both sides to get rid of this, so plus 6x, and then subtract 12. That will zero out this side. That gives me x squared minus 2x minus 8 equals 0. Now what I'm trying to do is factor this and solve by factoring. This does factor into x minus 4 times x plus 2. When I set each of these factors equal to 0 and solve, that will give me two solutions of x equals 4 and x equals negative 2. Now that I've solved that resulting equation, I still now need to check for excluded values. As we checked in the beginning and discussed, 4 is an excluded value because it made one of the original denominators equal to 0. In this case, then I have to reject this solution. The only solution to this equation would be negative 2.